Morning. Let's talk about the wrist. So, starting on our upper extremity lecture, and this will be exam 3 material, starting on the third exam. Muscles on your second exam will be lower extremity stuff, ankle, subtalar, knee, hip. And then your third test is going to be the upper extremity stuff. Okay? Wrist, elbow, radial, shoulder, scapula. So today we're going to talk about the muscles that influence the wrist joint. Now keep in mind 310 taught you the kind of joint the wrist is, a biaxial ellipsoid. It taught you the movement possibilities of the wrist being biaxial. We're going to have flexion pullers, extension pullers, ulnar deviators, and radial deviators. We do not have wrist rotators because, if you remember from 310, the wrist does not twist. That's your radial ulnar joint, okay? So how we look at this is the front view. What the world is that? Some chit-chit. So the anterior part of the wrist, the posterior part of the wrist. Remember in 310, you follow the fingers. Finger flexion is going to lead you to wrist flexion, no matter what your radial ulnar joint position is. Finger extension is going to lead you to wrist extension, no matter what position your radial ulnar joint is, okay? So our anterior muscles, the wrist is somewhat circular. As you're going to see when I put the wrist circle, we're going to look at a cross section of the wrist. Our bilateral axis is going to separate flexors from extensors. Our anterior posterior axis is going to separate, okay, let's look. This is a left. So I need to use my right wrist for this specific example. So we're looking at it like this, a cross section, or you can imagine clicking that and dragging it down, looking at it down your cross section. Okay, anterior, posterior, lateral, medial, flexors, extensors, radial deviators, ulnar deviators, front of class, back of class, outside, inside. Again, no spinners. The wrist doesn't twist. Okay, so we're going to have muscles that cross anterior, posterior, lateral, medial. Real pretty simple. Wrist is pretty simple. Once you get into that third dimension, once you get into the rotation stuff, that's when things get crazy. But when you have joints that only have, you sit in the front, back, right side, left side, and the class doesn't spin like a merry-go-round, life is pretty good, okay? Remember, to have function at a joint, a muscle needs to cross that joint, and its specific function is how does it cross? Does it cross? How does it cross? So the muscles being in the classroom suggests it crosses, and then how they sit in class designates function. Cool? All right. First thing I'm going to do is show you the class. I'm going to point out the muscles that we're going to be looking at. Maybe you want to pause it. Maybe you want to write them down on your support materials. Maybe you want to Google the muscles, and as I talk about them on the screen in black and white, maybe you want to pull up color pictures. It's all up to you. And again, the cool part about having videos is you could pause it, research it, come back to it, rewind it. Okay, lots of cool possibilities here, man. Okay. Hold tight. I'm going to go get the screen up. We're going to knock this out. Wrist is real easy. Wrist, radial ulna, elbow, and then once we get into the shoulder, that's a big class. That's like a 5A class of stuff, okay? So we got to kind of make our 3-foot putts, as I used to say in 310. I'm going to go pull up the screen. Okay, everybody. So the muscles that you're going to need to know, this is actually listed on your support material, so I don't need to scroll. You could just look at your support materials, and I'll read them off up here, okay? We're going to have flexor carpi ulnaris. We're going to have, let's see, okay, flexor carpi ulnaris, palmaris longus, flexor digitorum superficialis, flexor digitorum profundus, flexor carpi radialis, extensor carpi ulnaris, extensor carpi radialis, extensor digitorum. That sounds like a lot, but it's really not. I'm going to explain muscle by muscle, kind of how they get their names, their descriptors, based on kind of where they're pulling at. And you're going to see they're kind of real simple to learn, okay? So again, this sets up everything. Our bilateral axis separates flexion pullers from extension pullers, or muscles that pull in the direction of flexion from muscles that pull in the direction of extension, or flexors, extensors. That all means the same thing. And we need to be familiar with that so that we really understand what it means for a muscle to be placed into a group. Its direction of pull. How does it pull? Not how does it move. Radial deviation and ulnar deviation, pullers, muscles that pull in radial deviation, muscles that pull in ulnar deviation, or radial deviators, ulnar deviators. AP axis, lateral crossing muscles in anatomical are going to be radial deviators, medial crossing muscles are going to be ulnar deviators, okay? All right, that's the breakdown. Now let's get into the specific muscles. On to, ready, break. Okay, so let's first start off with the anterior compartment. Anterior compartment, you kind of think of it as an anterior apartment. Where do they live? Where do they cross? Where do they go? Where are they at? The anterior compartment, the front part, right? Another thing of note is these muscles, several of them originate way up here. A lot of them cross the elbow, medial or laterally. And they're meaty in the forearm part, but they turn into tendons, you know, roughly midway, a little past midway, and then they become inert strings. And when I say inert, tendons don't respond to electrical stimulation. They don't have actin, myosin. They're literally just stretchy ropes, right? Like stretchy ropes that pull. They do the bidding of the muscles that are pulling on them. Another way to look at it is if you are pulling on a rope, you represent the contractile components and the rope represents the tendons, right? You have to pull on the rope and then the rope pulls. So your force is being transferred through the rope. The muscle's force is being transferred through the tendon. And yes, the tendon can contribute, as we learned about that, but it has to contribute by being lengthened, right? This is why this is important. Hand dexterity, the little motions, the little intricate details that you do with your hands require a ton of nerves. You have to have a very equal ratio of nerves to muscle fibers, because you have to be able to move intricately. You in the lower extremity, it's opposite. You can have one nerve innervate a whole pasture of muscle fibers because it's very basic type motions when you're running, flexion, extension, flexion, extension. But when you get into the hands and the dexterity to draw, to move, to articulate, to work, to build tools, you have to have a very equal ratio so that you can control all that. So the point is you have a ton of wiring that comes off of your brachial plexus and eventually comes down to innervate all these little intrinsic little muscles, okay? Because you have so much wiring in such a small space. And not only that, that space moves around. You limit the amount of hypertrophy. In other words, it's easier for a muscle to hypertrophy way out here in the country than for a muscle to hypertrophy in the wrist, because there's no room for it to grow. It's like big city living, okay? So one of the ways our bodies can kind of take care of limited real estate, limited space, especially one that has movement, and to keep everything in order and not get too congested, because then you get the carpal tunnel syndrome and some other stenosing tenosynovitis for my athletic trainers, Finkelstein test and those kind of cool things. You need to limit how much stuff takes up space here. And one of the ways you do that is let the muscles grow out in the country and then pass along that force through inert, skinnier, non-hypertrophic tendons, okay, that they don't take up as much space, okay? So that's why you see a lot of white here and a lot of meaty muscle way up here, okay? Let the muscles grow out in the country, let them influence their functions in the city through these tendons. Okay, the first thing we have is this muscle called the palmaris longus. And remember, long is inference to tendon length, not to muscle length. So it's a muscle that lives out in the country, turns into a tendon relatively early compared to these other guys, and then that tendon runs all the way and inserts on these three metacarpals. On the palm, right? When you say that this is your palm, well, these are your metacarpals right here. I like to think of this muscle as the Spiderman muscle, because it kind of looks like if Peter Parker shot a web and then it you know, and it's on the wrist, right? And it pulls. So the palmaris longus. So think about muscles can only pull. This muscle crosses the wrist anteriorly. So if I was going to grab onto that string and pull, wouldn't it pull in a direction of wrist flexion, or a wrist flexion puller, or a wrist flexor? That all means the same thing. Whether you're at rest, it's pulling in the direction of wrist flexion. If you're dead, if you're a cadaver, it's pulling in the direction of wrist flexion. If it's working concentrically, pulling in the direction of wrist flexion. Eccentrically, pulling in the direction of wrist flexion. Isometrically, pulling in the direction of wrist flexion. You get the picture. It's a wrist flexor because of how it crosses. It crosses in the front. Now, the axis for radial and ulnar deviation is literally right here. So the palmaris longus, the way it sits, it's sitting the fence. It is neither ulnar side nor radial side. It's neither lateral, I'm reversing it as I see it here, but it's neither, do it here, it's neither lateral or medial. And when you're like, well, wait, isn't that opposite? Yeah, I'm trying to show you like this, how it would be in anatomical, but it flips it around and you can't see my finger here. So now I'm just kind of showing you what it would look like here. It's right in the middle, okay? It's neither pinky side nor thumb side, as we're going to see with our two next muscles in the anterior compartment, okay? Palmaris longus. Flexor carpi radialis and flexor carpi ulnaris. I'm giving these together because they're very similar. Flexor infers pulling in the direction of flexion. Flexor infers flexion puller. And again, guys, think about it. Flexor carpi radialis. If you learned, well, flexor must be flexion. It must be the motion of flexion. And I'd be like, well, how do you explain that muscle working eccentrically to allow extension? Flexor must be flexion. That muscle must always be responsible for flexion. How do you explain that muscle be responsible isometrically to prevent your wrist from extending if you have a weight in your hand? It's a flexor because it crosses the wrist in the front. Thus, it pulls in the direction of flexion. If it's the radialis, it's going to run along the radial bone. And remember from 310, the ulna is always pinky side. You can't escape it because the wrist orbits the ulna. The radius is always thumb side. So it's a good way to remember. And that's only, you could do that because the wrist doesn't twist. If the wrist spun in its transverse plane, then you could flip the thumb over to the ulna side, but you can't. So the pinky will always be ulna side, the thumb will always be radial side, whether you're supinated or whether you're pronated. Okay? So flexor pulls in the direction of flexion. That means it crosses the wrist anteriorly, crosses in the front. Flexor infers function in the sagittal plane. Carpi, it's a muscle that inserts on subcorpal bones. Which ones? Who cares? I don't care about that in undergraduate biomechanics. I want you to know function. Graduate school, you're going to maybe have to know where this thing inserts so that you could palpate specifically. You know, if there's an injury in there, you could palpate in there. Undergraduate biomechanists don't need to know that. You need to know function, because if you're a personal trainer, you need to know function. If you're a physical educator, you need to know function. And of course, our students that are working in clinics, you need to know function. And it's an introduction to function so that when you're in graduate school, you're going to have a leg up on all your coworkers because you're going to know what these muscles do in terms of their direction of pull. Flexor carpi radialis. So its sagittal plane function is given directly, flexor. Its frontal plane function is given indirectly, radialis. A radial deviation puller, because the radial bone, right, the radius in anatomical position is on the outside. Thumb side. Thumb side is lateral in anatomical position. So the flexor carpi radialis is a muscle that turns into a string that pulls along carpal bones on the thumb side. Therefore, it's going to pull in the direction of flexion, and it's going to pull in the direction of radial deviation. Flexor carpi radialis. Flexor carpi ulnaris. Okay? That's a muscle that pulls in the direction of wrist flexion. It's a flexor, pulls in the direction of wrist flexion, meaning that it crosses anteriorly. And it's going to pull on a carpal bone on the medial side, the pinky side. Okay? It's that little knob right here, that pisiform knob. But the point is that function is inferred. It's directly given with flexor, but it's inferred with ulnaris, ulna deviator. Okay? So you could even imagine the palmaris longus is going to sit in the front of class, but in the middle of class. The flexor carpi radialis is going to sit in the front right or front lateral or anterolateral. And the flexor carpi ulnaris is going to sit anteromedial or front left, as we're looking at a right-sided circle. Okay? Anterior compartmental muscles. Now I'm going to pull up the next slide and we're going to look at the finger flexors. Okay? Finger flexors. Follow the fingers. We're going to show you how that works next. All right. Now, first thing I'm going to show you is you have two sets of major flexors, and these are what we consider extrinsic, meaning that they get to your digits from outside of the hand. They come from, again, they live out in the country, and they exert their influence from the country to the city. Intrinsic muscles are little tiny muscles that actually live in the city and function in the city. Okay? They inside the hand, therefore they don't cross the wrist, so therefore they don't function at the wrist. Two sets. What I want you to notice is this set, the superficialis, it comes, you see the string, and then all of a sudden it kind of slits off and stops kind of at your knuckle here. Not this knuckle. These knuckles are metacarpal phalangeal joints. The superficialis stops here. These are your interphalangeals. You have distal interphalangeals, you have proximal interphalangeals. So they stop at the proximals, these guys. What's really cool is, if you notice, they make little slits. They make little tunnels. Look at those little tunnels. And what passes through those tunnels is these strings that go all the way to the tips, the distal phalanxes. So it's cool. The superficialis kind of opens up and makes a tunnel for the other group of flexor strings to pass through and then pull on the distal. Now, why is all of this kind of intricate stuff important? To hold on to stuff, to grip things, to grab things. You know, imagine grabbing something real heavy. If you're trying to exert upper extremity muscles, you know, think about, not mine, but think about some of you guys have big, powerful upper extremity muscles. What good is that if you can't transfer that force into something you're trying to tethered, you're trying to hold on to, right? It's live TV, folks. You're trying to hold on to something. You're trying to do that row with a lot of weight. You're trying to hold on to that toolbox. It's a lot of force. And so you need some mechanisms in place to have some big country muscles come in to work in the city, again, where there's not a lot of room to have big. Can you imagine your hands having like big hypertrophic, you know, hypertrophied country muscles? No. So your hypertrophy happens out here in the country, and your force is exerted through these strings. And I say this, I'm going to say it a few times. It takes a heck of a lot more force to hold on to stuff than it does to let it go. Think about it. You got a 70-pound dumbbell. It takes a heck of a lot of force to keep it in your hand, but it takes hardly nothing to let it go. You rarely use your finger extensors against any kind of resistance. It's finger flexors. You need to hold on to stuff. Okay? So we have extra hold on to stuff muscles here, as opposed to on the other side, as you're going to see, you just kind of have one major muscle to let it go. Now, some of the things we have in common with our toes and with our feet is the thumb has independently functioning muscles. And you have independently intrinsic muscles, like you have muscles that work the little finger, you have muscles that work your pointer finger, minimi muscles, indices muscles, thumb muscles. And again, it comes to dexterity. You don't do that kind of stuff with your toes. But you still have the concept of big muscles that come down to function at all of them. And that's when they're all trying to do something together. When you're holding on to something real tight, there's no intricate little, it's, we need everybody to help grab onto it, or we got to let go of it. So we have that mechanism in place. Everybody pull. Everybody pull. Okay? It's pretty cool. So what are their functions? Anteriorly, because they start in the country, cross the wrist in the front, pull on the digits, they're going to also pull on the wrist. Look at it from the side. Cross the wrist in the front, grab onto the fingers, pull on the fingers, pull on the metacarpal phalangeals, and thus pull on the wrist. So they are wrist flexors. When you average out this side, that side, this side, that side, they cross right in the front. So they are neither lateral nor medial. They have an average axis of anterior, so they're just going to be wrist flexors. Okay, there's a real cool trick. You could try this at home to show you how most fingers have their own independent intrinsic innervators, except for the ring finger. And there's a little trick you can do. Don't cheat. You take a piece of paper and you put it in between your ring fingers. Okay, so you see how it's on my ring finger? And you do the whole, this is the church, this is the steeple. I like to look at it as a bridge. You make a bridge with your middle fingers. Now here's the key. You have to keep your bridge connected. You can't cheat and like make the bridge come up, okay? And you can't pull your fingers apart. So this is to show you that I have independent pointer finger muscles, independent pinky muscles, independent obviously thumb muscles, but if you keep the bridge, you can't let go of the paper because your ring finger is bound to the other fingers. You have to do them all together for it to work. Okay, it's kind of cool. Try that and let me know what you think. All right, anterior compartment muscles, palmaris longus, flexor carpi ulnaris, pinky side, flexor carpi radialis, thumb side, flexor digitorum superficialis, and flexor digitorum profundus. Got it? All right, let's move on. All right, let's look at the extensors or the posterior compartment. This should be super easy. Remember in the ankle and subtalar, we had a lot of mirrored muscles. We had a tibialis anterior, tibialis posterior. We have a flexor digitorum, we have flexor digitorum, extensor digitorum. Here we have very similar concepts. We had flexor digits. Well, like I said, now we're just going to have one muscle that lives out in the country that's going to pass on to our digits 2 through 5. That's just going to pull in the direction of extension. You don't need backup. You don't need a ton of muscles to let go of stuff. That being said, naturally, you could understand that there's an imbalance with these muscles, that you got more fatigue-resistant muscles that grip than ungrip, because you need not only more to grip, but technically, the harder you squeeze, the more inhibition you want to have of your finger extensors, okay? Which I'm going to show you a couple more cool tricks about stretchy insufficiency later. It's kind of neat. Anyway, extensor digitorum doesn't have to be a big powerhouse to let go of stuff. Then you have, we had flexor carpi ulnaris and flexor carpi radialis, pinky side, thumb side. Well, we're going to have the exact opposite. We're going to have extensor carpi ulnaris, pinky side, and extensor carpi radialis, thumb side. And the beauty of these muscles, the carpis in the front and the carpis in the back, is that in the sagittal plane, these two cancel out frontal plane pull. In the sagittal plane, these two cancel out frontal plane pull. But in the frontal plane, the flexor carpi ulnaris and the extensor carpi ulnaris cancel each other out in the sagittal plane and work together to pull pinky side. And the same thing on the radial side. Flexor carpi radialis cancels out extensor carpi radialis in the sagittal and can work together to pull in the frontal. So when you're holding a weight, like in a hammer grip position, right? Wouldn't you need your radial deviators to prevent ulnar deviation? So you have these two radial deviation pullers canceling each other out in the sagittal, pulling in sync synergistically in the frontal. Super cool. So, and that's super easy because, again, we have precedent. We have two carpi flexors in the front, ulna and radial, and we have two extensor carpi in the back, ulna, radial. We have two sets of flexor digitorum, which makes sense because we need more muscles to grip. And we have one set of extensor digitorum because it's easier to release than squeeze. Okay? All right. Let me show you another cool trick about the uniqueness of the digits. As you know, if you're real tight and somebody's stretching your hamstrings, you're going to cheat. You're going to move your pelvis. You're going to go along for the ride because if the muscles are real tight, you're going to move other places to get it over. This is really cool. My extensor digitorum pulls in the direction of wrist extension. So therefore, remember, we're going to talk about stretching. Direction of pull, opposite motion. Okay? So how do I stretch wrist extensors? By flexing. But what if one of my wrist extensors also happens to be a metacarpal phalangeal extensor and a proximal interphalangeal extensor and a distal interphalangeal? In other words, it extends a lot of different things around the chain. This is so cool. If you take your pin or something else you can squeeze and you squeeze it, and you kind of get a sense of how much force you can squeeze. Then what I want you to do now, think about it. I may not be stretching the extensors at the wrist, but I'm stretching it here at the metacarpal phalangeals. I'm stretching them here at the proximal and interphalangeals, and I'm stretching them here at the distal. I'm stretching them in 1, 2, 3 places. They're being stretched. If I start to flex my wrist, I stretch my extensor digitorum so much that literally they get in the way of me squeezing my pen. The passive stretch is so much that it's literally pulling my fingers away from the pen. Try that. Try to squeeze your pen with your wrist flexed, and you're like, oh, why is that not working? Because these muscles are being stretched so much that they're literally pulling back. Their own passive stretchiness is getting in the way of your finger flexors trying to work. They're being stretched too much. It's pretty cool. That's called passive insufficiency. That's a really neat concept. Okay. Let's get back to our circles and sum this up. All right. So rapid fire. Who are your wrist flexors? They are all the muscles that cross anterior to your wrist. Palmaris longus, right? Flexor digitorum superficialis, flexor digitorum profundus, flexor carpi ulnaris, flexor carpi radialis. What are your extensors? The ones I'm holding you accountable for. Extensor carpi ulnaris, extensor carpi radialis, extensor digitorum. What is the specific function of the flexor carpi ulnaris? One is an obvious function. It's a wrist flexor. The other one is an insinuatory function. It runs along the ulna, so it's an ulna deviator. Really that simple. Palmaris longus, muscle that inserts on the palm of the hand, palms in the front, must cross anterior wrist flexor. How would I stretch the palmaris longus? Well, since it pulls in the direction of wrist flexion, I need to extend the wrist. Okay. And again, understanding that the flexor digits cross the wrist to get to the fingers, if I really wanted to stretch the superficialis and profundus, I don't want to just extend the wrist. I'd love to extend the wrist and extend the fingers to really stretch it out like that. Comme ça. Okay? So that's the wrist, the muscles and the function. I'll do a practice video, and then after the practice video, we'll move on to the elbow radial joint, practice video, shoulder, practice video, scapula. We'll see how it goes. I may do the practice videos as a supplement to this lecture instead of a standalone lecture because we only have so many days, right? Okay, if you have any questions, let me know. Hope you guys are well. Bye-bye.